So, cache savings says to write a function that takes a callback and returns a new function that takes one argument. So when the new function is called for the first time, it should call the callback with the argument and save that result. So if that result exists already, if we've done that already, we shouldn't be calling that function again. We should just be taking it from the cache. Okay? Does that make sense to everybody? Basically, if we've called something with a certain argument already, we should not have to call that function again if we already have the result saved somewhere. And that's exactly the kind of function we have to write. So I will go ahead and say const cache savings equals a function, and this function will take a callback. Okay? So now this thing has to return a function, right? So we can do return an anonymous function, like so. And this function should be taking an argument, right? And I will call that arg, because that's what I choose, okay? So right now, cache savings does what the problem tells us to do, right? So, but what do? We have to check and see if this argument has been called already. The answer, the thing that we could do, the data type that we can use, is something with constant lookup time. Something where if we know the key, we can see if that value has ever been run before, right? So we can use an object. The reason why this is because if we have seen this argument before, the argument can be the key, and then the result will be its value. So, in doing so, before this function does anything it's supposed to be, in that function, it will have access to this cache because of closure, right? So, before this function does the rest of its logic, we will check to see if it is in the cache already. And if it is not, then we run our function and get a result, and we put it in the cache. Then we can just return what the cache has. Because of closure, this anonymous function will always have access to that cache. Okay? And that is the basic logic behind this problem. So basically, we can do if arg, well, we can use the in operator, if arg in cache with the bang, right? So we are checking to see if this is not in there. Arg in cache will return true if it is inside of it. But since I wrapped it in a parentheses and I put the bang operator in front of it, this means if it's not inside of it, okay? And this is more direct. This is more a direct way of checking if something is in here. Otherwise, because you can also do this, right? If cache of arg. If cache of arg exists. However, what if the result of this function is the number 0? I always think about this because 0 is a valid value, you know? It's not like a mistake, like undefined, you know? You can also check for undefined. However, there could be like a result that is undefined as well. I don't know, you know? But these are all valid values in JavaScript, right? So, using the in operator actually looks for the key, right? And it returns true if that key is inside. So, if the key is not inside, then we will say cache at arg is now going to be equal to that callback invoked with arg. So the cache is now going to have a key of whatever that argument was. And its value will be the return result of that initial callback with arg passed in. So now, outside of this if statement, we can just do return cache of arg. And then this should work. Dope. Any questions? This was definitely a tricky problem, you know? I didn't really expect anybody to get this, especially the way the question was worded, you know? A little bit more thinking had to be involved, in my opinion. So if you didn't get it, that's cool. But do you now understand how this works with the concept of closure? How this function, this anonymous function that I'm returning right here, has access to that callback and has access to that cache. So if that has access to that cache, we can store all the results. And then this callback doesn't have to run. We don't have to run this callback if we already have, if this is already in there, right? Yeah.
You do it without using an object.
What, like using an array? I mean, like, I wouldn't. I don't really know if you could, right? Well, yeah, you could. You could use an array, and then instead of checking to see if this is, like there's the key in the object, you would have to loop through the array every single time, and then look for the argument inside of the array, right? And that will just get longer and longer and longer the more times you call the function, right? Because the more time you call the function with different arguments, you'll be just pushing and pushing and pushing to this array, right? So that would be less performant. But yeah, you can do it that way if you wanted to.
What about how the question was worded that immediately kind of like, or like prompted you to say we want to like drop this into an object? I think it's kind of like that. Like I was trying to like put a stored value just as like a number and matching like arg.
Usually, when I want to store values that I want to look up later, object. That's that, you know? And you don't know the type of value, you don't know anything about it, you need an object, pretty much.
Storing values, the way to go is objects.
Pretty much, yeah. If you need an object, if you need to put a value inside of something and you know you're going to need it later, like to look it up later, because you can't use an array for that. I mean, you could, but you would have to do a for loop and look through it every time. Because there's no way to store the index, you know?
Yeah.
It usually shouldn't be a number unless you know for a fact you're returning numbers, right? However,
in this case we did, but yeah.
We don't know that we're returning numbers, right?
I guess in the
Like this function just has knowledge of a callback and has knowledge of an argument. The example could have used whatever it had, right? But it could be anything, you know? Any other questions? You guys good on this? Okay. So now we are going to look into recursion. Okay? So, there are two major things we are going to learn today. One of them will be recursion. The other thing is something that is specific to JavaScript in general, okay? And that is called the call stack. So, everybody listen. JavaScript is single thread. That means that it can only run one function at a time, okay? So, Before we talk about recursion, we have to talk about how JavaScript knows which function is running at what point in time. And the way it does that is it uses an internal tool called the call stack, okay? And I will show you in a very small way how you can visualize the call stack, okay? It's very simple. So let's say I have a function that's called says hi, right? Whoops. And all it does is console.log hi, right? And then I have another function that's called says yo. And all it does is console.logs yo yo yo. And then at the bottom of the page, I will invoke says hi, and then I will invoke says yo. This isn't anything weird or new or hard for anybody, right? These are just two regular functions that are just console logging strings. And then at the bottom, I'm going to run them, okay? So I'm going to scroll up a little bit, and here I will have the call stack, okay? So when JavaScript runs this application, it sees that you are calling a function says hi. That means that says hi goes onto the call stack, okay? Then says hi runs. When says hi is done running, it goes off of the call stack. Then we can continue to line 24. Now we're at says yo. So says yo is invoked. So says yo goes onto the call stack. Says yo runs. We get the console and we get the console log and the terminal. And then says yo finishes running. And then it is removed off the call stack, right? And that's what happens. That was that easy to understand? Right? The function starts running. Then it goes onto the call stack. Then it finishes running, and then it is removed from the call stack. Okay? So, what if I don't call says yo here? I call says yo here. Inside of says hi. Okay? So what is going to happen now? All that is happening, these are just function definitions, right? Says hi calls says yo, and then it console.logs hi. Says yo, just console.logs yo yo yo. This is the same thing, right? And then outside of here, we hit says hi. So, says hi is on the call stack, right? Says hi starts to run. Then, on the first line of code inside of that function, we have another function that is being called. So that means that says yo is now in the call stack on top. Because says yo is the topmost function and JavaScript can only run one function at a time, that means says hi is in a state of pause. It has paused running. It is no longer running at the moment because says yo has to run, okay? So says yo, console.logs, yo yo yo, and then says yo is removed from the call stack. So now we are back to that initial call of says hi, and then on line 17 we see console.log hi hi hi. I mean just hi. So then after that runs, we can take that off. And now you see the order is switched, right? Like if I wrote right? So you see yo 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 finishing. Then you see the hi, and then you see says hi finishing. Right? Does that make sense to everybody? So that was my little introduction on what the call stack is. And you will see how this is important once I show you a recursive example, okay? But I keep saying recursion, 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 right? So what actually is recursion? Recursion is the act of a function calling itself, okay? That is what recursion is. Think of it as like looking into a mirror this way, and then there's a mirror behind you, right? So it's like down into the mirror, into the mirror. That's like what recursion is. Recursion is an alternative to iterating. Anything that you can solve with a loop, you can also solve with recursion. Recursion is confusing. Recursion is hard to grasp, definitely the first time, and for more senior developers always, okay? Some people grasp them more quickly, some people don't. However, you guys remember when you learned about for and while loops the first time, right? And some of you asked me, why would you ever use a while loop? Some problems are just easier to reason about using while loops, okay? The same principle falls with recursion. Some things actually do make more sense to do recursively rather than using a loop, okay? You will find that out later. Right now, you just have to know like the process, the basics of recursion and what happens. And now that you know about the call stack, this will become a little bit more easy for you guys. And I will show you right now. So let's say I wanted to write a function that counts down from 5 to 1 and then says done. Okay? Well, not the done, just 5 to 1, right? You can do that with a loop, right? Like a for loop, I is 5, console log I, and do this like that, right? However, you can also do this by calling the same function itself over and over, okay? So, I will show you, okay? So, if I have like a const count down that takes a number, okay? It will take a number and whatever number you put in there, it'll count down from that number to 1, okay? So, what I said was just recursion is when something calls itself, right? So that means that in here, I would write countdown none. This would indeed call itself over and over again. What do you think would happen if I ran this code? And I wrote running up here. What do you think would happen? It'll just go on forever and ever and ever, and that's how we have an infinite loop, okay? Getting stuck inside of infinite loops is a lot more common than getting stuck inside of infinite loops when iterating, okay? As you can see, if I were to run countdown would run, we would see running, and then countdown would run. And then we'd see running, and then countdown would run. And then we would see running, and then countdown would run. And it would never, ever, ever stop, okay? So, how can we stop this function? How can we tell this function when to stop? In for loops, it's usually like when I is less than the array dollar. When I is less than the string dollar. When I is less than 10 or something, you know? So how can we do that if every time you call countdown, any variable you would set would just be reset, right? If we said let count in here equal 0, and then say like if count is 10, stop. But like every time you run countdown, count would be reset, right? So here, I can write an if statement, and I could say if num is equal to 1. We can return undefined. Or we can just return. Yes.
Does the break keyword work here, or it's not the same?
Break and continue are very specific to for and while loops. Break and continue will not work with this because all we're doing is calling functions, right? So if you ever tried to use the break keyword in something outside of a loop in a different function, you would get an error, I think. Anyways, the break and continue keyword will not work here. However, what keyword stops a function no matter what? Return, right? So if num is 1, we can return, right? And yeah, we will do console.log done. Okay? And here, we will console.log num. But wait a second. If I was to do countdown of 10, 10 would go in here. We would console log 10. Is 10 equal to 1? No. We would skip this. And then we would just call it with 10 again. What one-liner can I just put in here to solve our problem? Minus minus, or just minus 1 here, right? So, if I were to do this, we get 10, 9, whatever, down to done. Okay? So, I'll do it with 5, and I will go over with you how you can actually keep track of this by either mentally or physically typing out the call stack. Okay? So if we have the call stack, and so we call countdown with 5, right? That's the first thing we're doing, right? We define countdown here, and then we call it with the number 5. So that means that onto the call stack goes countdown of 5, right? Like this example up here, that made sense, right? You just called the function, it goes on. We called countdown with 5, so there it goes. So what happens? Countdown runs, num is 5. We console log 5. We check and see if 5 is equal to 1. It isn't. And then we call countdown with 5 minus 1. So we are now calling countdown and passing in 4. Does that make sense? So now, countdown with 4 goes onto the call stack. Console.log num, we get 4 in the terminal. Okay? We check and see if 4 is 1. It isn't. So we call countdown again with 4 minus 1. We call countdown again with 3. And the pattern goes on. Okay? We call countdown again with 2. 2 goes in. Is 2 1? No. Countdown 2 minus 1. We call countdown with 1. Oh, shit. So when countdown of 1 goes through, console.log num, we console.log the 1, and then if num is triple equal to 1, that means that it's true, and we get the done. Then we return. The return keyword makes this function stop, right? This is what's actually happening. Now on the call stack, countdown of 1 is completed. We returned nothing. We returned undefined, okay? So that means that this is done. If that's done, then we take that off of the call stack, and now we can continue countdown of 2. We left countdown of 2 off when we called countdown of 1 down here. but countdown of 1 returned undefined. So that means countdown of 2 can continue running after this line. Nothing happens, so it implicitly returns undefined. And if it implicitly returns undefined, this function is done running. So now, countdown of 3 can finish running. Because if you remember, when we called countdown of 3, we were waiting on countdown of 3 minus 1, right? 2. 2 just finished running. It returned undefined implicitly because nothing happens after here, and countdown of 2 returns something. So, we can take this off the call stack too. Countdown of 4 was waiting on countdown of 3. Countdown of 3 returned undefined implicitly, so countdown of 4 can return undefined implicitly as well. And countdown of 5 can turn undefined implicitly as well. And you can see the undefined here. That is what actually happens, okay? This is important to realize. You need to visualize this call stack, okay? When functions get called, it goes on. Then countdown of 1, we hit this, and it returns undefined. So if this returns, then this is off. So that means where this was countdown of 2 minus 1, this can finish running this function, countdown of 2. However, there's nothing left. And if you don't return anything in the function, then it returns undefined implicitly. Does this make sense? Sort of. Does everybody think that if they stared at this for a little bit, they would understand it completely? Does everyone think that the logic is sitting there in front of you, and it's just like a little confusing? Because that's what I think about recursion, right? I think the logic is in front of me and it's staring me in the face, but it just takes me a second for it to click, okay? And I think that will happen with all of you, okay? Does anyone have any questions on this example?
I do.
Yes.
It's really question, but when you do minus, it doesn't work the same. Is it because it's not a for loop, and you have to do like a minus?
No, not minus minus. Does return. Hush. Did it again. So what num minus so num minus minus and num plus plus, like, they return values. They return the value and then they decrement it and increment it. So num minus minus will return num, but if that means that returns num, then this function can start running, right? So it doesn't wait for it to be reassigned. Like this will work, but minus minus will not. Because minus minus is not actually, it is not literal shorthand for minus equals. Plus plus is not shorthand for plus equals 1, okay? It's not. It returns the value first, and then it increments. Yeah.
Can you also console log num after you run countdown?
Like here?
Yeah. And then the num.
Yeah.
Why does it do that? Why does it count out?
When this is done running, when countdown of 1 is done running, right? We get here. We get the done, and then it returns. So this is now off, right? So then countdown of 2 can finish running. Because countdown of 2 was waiting for countdown of 1. Right? But countdown of 1 returned. So we get a value back from that. We get a value back from that. So this is like undefined. This is done running. So we can continue. But this whole time, we're in countdown of 2. So the current number is 2.
So why did it log out and stop the not? Why did it still log like if you did the just no -1?
Because when we call it originally with countdown to 5, the first thing that happens is console.log num. Console.log 5. It goes down all this stuff, and then it hits countdown of num -1. So we do countdown of 4. So then countdown of 4 goes on to the call stack, and then we console.log 4. And that happens and happens and happens. That's the only thing that's going to happen, right? We're always going to skip over this if statement, and we're always going to hit this function call, this recursive function call. And we'll always pass in 1 less than the original number, right? So that's why we get 5, 4, 3, 2, 1. Oh, wait a second. We hit this if statement. We hit our base case. This is a base case. Num equals 1 is true. So we console.log done, and then we return. So that means since we hit this return keyword, this doesn't run anymore. Line 38 and 39 do not run in countdown of 1. Okay? So that means since we returned, then we can finish running countdown of 2. The whole time, countdown of 2 was paused on countdown invoked with 1. Countdown invoked with 1 returned, so then we can finish running countdown of 2. The next line on line 39 is this, console.log. And countdown of 2, the num, is 2, right? So you could see, done in 1, and then 2, 3, 4, 5. Countdown of 5 will finish running last.
On the call stack, I understand only one runs at a time, but is there a way to see or like so like an actual reference to the call stack to know like, all right, all these functions are in queue to go, and this is
Is there a way to see that happening?
yeah.
I think a quick answer is maybe. But like the thing that comes to my mind is using the Crove DevTools and the debug keyword, which isn't supported with REPL, but it is supported in CodePen. And then because there you could just pause your function and go next, next, next every time and see what every value is. But that's not actually the call stack. I can do some research on it and get back to you guys if you want. I feel like there should be a way to do that in like Chrome or something, but I have no idea.
I just imagine that there's some like benefits to knowing like this is the queue or this is the order of operations given how things are currently designed.
No, I feel you. Yeah. Any other questions? Who feels comfortable? Nice. Nice. I think the slides actually help a lot. I usually don't really like the slides. But I think the recursive slides really help because it really gives you a nice visual of the call stack, okay? And it gives you a more complicated example than this console log nonsense, okay? So, without further ado, let's get into it, okay? All right. So in this lecture, we'll talk about what recursion is. We'll talk about the call stack. I'll go through quickly it's the same example. I'll go through the countdown example again, and then I'll do a factorial example. And then I'll talk about recursion with arrays and strings, which is a little different. Not really, but the base case will be different. And then I'll talk about tips for approaching recursive problems, okay? So, recursion. Recursion occurs when a function calls itself, and recursion is an alternative to using a loop, okay? I said this. If you can solve the problem using a loop, you can solve the problem using recursion, okay? Sometimes, if you're getting stuck, so like all of the problems in the workshop today, you can just solve using a loop, right? There's no way to check that you're using, well, there is, but like, if you get stuck with your recursive solution, sometimes some people find it helpful to first solve the problem with a loop, and then backtrack and say, okay, now that I know how to do this with a loop, how can I do this with recursion? That's just a tip from me to you, okay? So in the real world, you may see recursion instead of iteration when a recursive solution is easier to reason about. Recursion helps break big problems into small chunks, or when sometimes it's easier to read than an iterative solution, and it won't affect performance negatively too much. But recursion can actually be a memory hog. But like, don't worry about that, okay? Machine learning, AI, traversing data structures. Okay? So. Before we talk about recursion, though, we have to talk about the call stack. So like I said, JavaScript is single-threaded. That means it can only run one function at a time, right? So the call stack is what JavaScript actually uses to keep track of which function should be running at every point in time, okay? So whenever we call a function, it's added to the top of the call stack, right? And JavaScript will execute whatever function is at the top of the stack. And as you can see here, as we run this, first goes onto the call stack, right? Then I am first appears in the console, right? Because first, console.logs, I am first. So after first is done running, first is off of the call stack, right? Then second runs. So then we see I am first, I am second, right? And then second gets taken off of the call stack. And that's that. Does that make sense? A function is called, it goes onto the call stack. That function runs. When that function is done running, it is taken off of the call stack. And we continue reading our application. Okay? Not too bad, right? So, I showed you an example like this as well. So first now calls second inside of it. First now says console.log I'm first, then it calls second, then it says console.log first is finished. And second says I am second. Down here we only call first. So that means, since those two are function definitions, and we have one function invocation down there, first goes onto the call stack. We see I am first up there, okay? I am first, and then second goes onto the call stack. And then when second runs, we see I am second, right? And second is then taken off of the call stack. And that whole time, first has been paused while second was running. But now that second is finished running, it's not on the call stack anymore. First is not paused anymore, and first continues to run. So that's why you see first is finished. Does that make sense? No recursion yet. This is just understanding how the call stack works. First is paused while second runs inside of it, okay? First cannot finish until second finishes. Okay? Good? So, and then second gets taken off. So write a function that counts down to 1. So this is easy to do with a loop. For let I equal num. I is greater or equal than 1. I minus minus. You console.log I. You call countdown of 5. And there it is. Right? 5, 4, 3, 2, 1. Easy to do with a loop. Easy. So, let's make it more complicated and use recursion. So, if we do this, we can just say countdown 5, countdown 4, countdown 3, countdown 2, countdown 1. And we're not using loops, right? We can do this, but this is not programmatic. Okay? This means we have to call this function, and as humans know, make 5 one less every time, right? So this is not the right way to do anything, right? We want to simplify things because that's what programming is all about. Automating everything, okay? So what if every time we called countdown, we subtracted 1 from the previous num? Instead of manually calling countdown over and over, why not have countdown call itself, subtracting 1 from num each time? Cool. So countdown of 5 goes on, and we see console.log 5 up there. Then countdown of 4 goes on, and we see console log of 4. Then we see the 4 over there, right? And then 3 goes on, and then 2 goes on, and then 1 goes on, and then 0, and then negative 1, and then negative 2, and so on. And finally, you get the range error, maximum call stack size exceeded, okay? The same error you get if you were accidentally inside of an infinite loop, okay? Same thing. The reason why this happened is because we never told this when to actually stop, okay? Sure, we decreased the number every time, but we never told it when to stop. That started off promisingly because our function was instructed to call itself every time. The function ends up calling itself forever until our computer runs out of memory. Okay? Okay. Does everyone understand why that happened? We never told that thing when to stop. It just kept calling itself with 1 less every time, until negative infinity. But the computer ran out of memory, so it stopped. So let's write in a stop condition so the function eventually stops calling itself. Here's our stop condition. This is known as a base case. It's some lingo. Throwing some lingo at you, okay? Lingo. It's called a base case. If num is less than 1, console.log done. Else, console.log num, and then call countdown num minus 1. So countdown of 3 goes on there. 3 goes in. Is 3 less than 1? No. So we go into this else, and then we console.log 3, right? And then we call countdown again with 3 minus 1. Countdown of 2. Is 2 less than 1? No, it's wrong. So we go into that else, and we console.log the 2, and then we call countdown again with 2 minus 1. So countdown of 1 goes onto the call stack, okay? Is 1 less than 1? No. 1 is 1, okay? So we will see console.log 1 in the terminal, and then we will call countdown again with 0. So now 0 is on the call stack, okay? If 0 is less than 1, that is true. So we console.log done, right? And this is in an else, so the else doesn't run because the if ran, right? So that means we skip this recursive call. So we go to the bottom, and then countdown of 0 just returns undefined. Okay? So countdown of 0 is taken off. Then countdown of 1 is taken off. Then countdown of 2 is taken off. And then countdown of 3 is taken off. Because if that returned undefined already, then when we were back here, countdown of 1 minus 1, 0, this returned. So that means countdown of 1 can return there. And it goes back and back. Does that make sense? Any questions? My bad. Any questions? Don't be shy. All right. 2 takeaways from Countdown. You need to define a base case. So, tips with recursion. Define your base case first. Okay? You need to know when to stop calling your function recursive. You need to know that, or else you will have big, big problems. Okay? You need to define your base case first. It will only help you. Okay? It will only help you. And your recursive case must change the input to the function. That's how, like, in a while loop, you would increment I, right? Here, we have to change the thing we're passing in. We have to change that argument's value in some way that will actually hit that base case, right? So as you can see, we've been using numbers this whole time, right? So, like, that means that we just decrease the number or increase the number each time until that base case is hit. Can anybody think, just think for a second, what a base case would be if we were doing something, a recursive problem with strings or arrays? What is a common, if this is this, return this?
Triple equals.
No, yeah, but like, what should we compare? What should we be looking for? Like, the whole time we were looking for if, like, the number is 0, if the number is less than 1, right? So what's a good thing to check for strings and arrays? Dot length, right? But I just said that we have to change the input every time. So if we're checking to see if dot length is 1 or 0, what's a good method to use to get rid of one thing each time? I wouldn't do pop because pop mutates things, and if you're mutating and doing recursion at the same time, something weird might happen. Slice. Right? I'm just thinking ahead right now. If you do dot slice and pass in a 1, we get the entire thing minus the first thing, right? So eventually, that base case would be hit. That's usually the go-to base case when dealing with problems with arrays and strings, okay? Usually it's off of the length of the input, okay? So now let's talk about returning from recursive calls. I didn't show you this because I think this is better explained here, okay? So recursion becomes more complicated, and it really does when the function must return a value, okay? And good practice is to start by defining a base case. Base cases are often occur when there is a simple input that expects a simple output. Like the sum of a single number is that number, you know? Test that the base case works before working with the recursive case, okay? Test it with a very simple input and make sure that it gets hit. Like in the countdown thing, if the number is less than 1, return, right? So a good way to check before you do anything is like pass in 2 and see if that hits eventually, you know? It'll save you a lot of headaches, okay? So now we're going to talk about this factorial. We're going to write a function that's going to take in a number and give you that factorial, okay? And if you guys don't know what factorial is, that's cool. That is not what this class is about, and I really don't care if you know it or not. But factorials is basically this. Like factorial 5 would be 5 times 4 times 3 times 2 times 1. It's the number times every number decreasing to itself to 1, okay? So factorial 4 would be equal to 4 times 3 times 2 times 1. Factorial of 2 would be 2 times 1. factorial of 1 would be 1, and factorial of 0 would be 1. Who, by looking at this source of truth, can tell me what the base case will probably be? If the number is 1 or 0. Correct. Huh. So, like you guys just determined, factorial of num, if num is triple equal to 0, or if num is triple equal to 1, okay? We return 1. Why am I returning 1? What is any number times 1? Itself, okay? If you multiply any number by 1, it is that number, right? So that means that the product that we are increasing over time will not be affected by returning 1, okay? So factorial of 0 and factorial of 1, we get 1. Boom, we're done. No, we're not. We have to solve it if it's 2 now, okay? So the base case is set, and we just need to remember that our recursive case has to bring the number closer and closer to 1 or 0 so we can eventually hit our base case. Notice an interesting pattern. So like this should be 5 times factorial of 4, 4 times factorial of 3, 3 times factorial of 2, 2 times factorial of 1, right? This is what should happen, right? If we want to get the number to 1 or 0, we have to subtract it by 1 every time we call it again, right? So this is what it will look like, okay? So here we have the same thing we had before, right? If num is equal to 0 or if num is equal to 1, we return 1. So the num must get closer to 0 or 1. So it's best to write your recursive case using the simplest possible input that will result in a recursive call. So let's do let result of factorial 2. We get undefined for now, right? Because if 2 goes in here, nothing happens. So undefined is returned. So let's handle this. So the num must get closer to 0 or 1. So we know we have to call factorial again in the recursive case. So if num is equal to 2, what do we get if we call factorial again with num minus 1? We get 1 and then undefined. Okay? Because if we console.log down here, if we pass in 2, this doesn't run, and then factorial of 2 minus 1 runs, then we get the 1 from there. So this will console.log 1, and then factorial of 2 can finish running, and that's why we see the undefined. Does that make sense? Is anyone confused by this? Anybody? You guys promise you're not confused by this? All right. So, from that pattern we noticed earlier, we know 2 factorial is 2 times 1, right? So, if we do console.log num times factorial of num minus 2, we get the correct factorial of 2, right? We're just console logging, but now we get the actual factorial by doing that number times the factorial of num minus 1, which would be 1, right? So 2 times 1 is 2. Does everyone get this? We're not really solving the problem yet, but we are getting a little closer, right? So, recursive case, num must get closer to 0. Okay, now we just have to return the result now, right? So now we can say let result is now going to be equal to num times factorial of num minus 1. And then we return result after that. So if we call let result a factorial of 2, we get 2, okay? We get 2 here. There's no more console logging here. We have run our thing, And result out here is now the number 2. This will be explained a little bit better with this call stack diagram up here, okay? And we will do this by calling factorial of 5. So, same function as before. We hit let result equal factorial of 5. So that means JavaScript has to figure out what factorial of 5 returns, because that value has to be assigned to result, if it's undefined or if it's whatever. You made it, you know? So factorial of 5 has to run. So factorial of 5 goes on to the call stack, right? So let's run factorial of 5 together, slowly. So num is 5, right? Is num 5? Num is 5. Is num equal to 0 or 1? No, because it's 5, and that doesn't make any sense. So we say let results inside of this function. Now we are saying let's declare this variable result, and we're going to set it equal to 5 times factorial of 5 minus 1. So results will be equal to 5 times factorial of 4. Wait a second. It's 5 times a function invocation, so that is going to go on the call stack, right? 5 times from factorial of 4 will be the return value of that. So then factorial of 4 goes on the call stack. That means factorial of 5 is paused, okay? Factorial of 5 is paused now because we have to find out what factorial of 4 returns. And if we do that same logic again, factorial of 4 returns 4 times factorial of 3, right? Does that make sense? Is everybody with me so far? And we're going to go down, and 4 minus 1 is 3, so it'll be 4 times factorial of 3. So that means we have to see what factorial of 3 returns. So factorial of 3 has to be invoked, so factorial of 3 goes onto the call stack, right? Running the same logic again, we say result is now going to be equal to 3 times factorial of 2, right? So then we have to call factorial 2. Factorial of 2 is called. Running the same logic, we have to do 2 times factorial of 2 minus 1, factorial of 1. So we call factorial of 1. Factorial of 1. Num is 1. If num is equal to 0 or 1, return 1. We have finally hit our base case. We hit it. We don't have to see the rest of the code in factorial of 1. We just return 1. Okay? And as you can see up here, factorial of 1 returns 1. Right? And then looking ahead, factorial of 2 should return 2 times factorial of 1, right? And factorial of 1 is 1, so this should be 2 times 1, right? Does that make sense? So factorial of 2 returns 2. Looking ahead, factorial of 3 returns 3 times factorial 2. Factorial of 2 returns 2. So factorial of 3 returns 3 times 2. And then factorial 4 returns 4 times factorial of 3. Factorial 3 just finished returning. It returns 6. So since that's done running, then we have a value here. So we get 4 times 6. So factorial of 4 returns 24. Then, since factorial of 4, we got the return value, it's done running, we remove it from the call stack, and then we have the return value of factorial of 4 here. So that means factorial of 5 will return 5 times 24. So a factorial of 5 returns 120, and we are finally done. We can finally hit line 12 because result was assigned the value 120. and our call stack is empty, there are no longer any functions running. Did this help you understand it a little bit more? Returning values is vastly more complicated, okay? Vastly, okay? I'll tell you that right now. But if you yourself go into like a REPL or even in your code pen or whatever, and write a call stack like that, what the function is running with what argument and what its return value should be, then you will slowly see. It will be tedious. I promise you, it will suck. But it will help you understand what's happening, okay? Because that is the hardest part about recursion. Understanding what is happening at each point in time. Because there is no reference to an I, like there is when you're iterating. We can't say, oh, okay, well, we hit I here, so it got up to the 20th index and then something went weird, you know? Now we don't really know. So it's important for you guys to visualize the call stack. And it's very important for you guys to not start out with like, okay, I wrote my code for the first time. Let's see what factorial of 2000 is. And then try and debug that. No. Try with 2 and then 3. Try with very simple inputs that expect simple outputs. That is how your lives will be easier, okay? Any questions on the solution for factorial? Any questions? You guys get it? You understand it? Yeah, I can tell. It's tough, okay? Trust me, it's tough. But the logic exists. That's the most important thing to remember, you know? It's not like this is impossible. It is possible. I just showed you how it's possible. It's just this is very, very new, okay? So it's very hard to wrap your head around it, okay? It's fine. Like I said, it's like looking into the mirror, right? And then you see like, you know? Okay. Oh, what's next? 3 takeaways from factorial. Write your base case first. You don't have to do anything. You're your own person. Do whatever you want. However, if you want to not be miserable, please write your base case first, okay? You have to know when the function's stopping, okay? That's important to figure out because the base case is not always apparent. I will tell you that. It's not always apparent. But usually you can find out what the base case is, what the function should be returning, you know? So like if you're writing a function that should return a number or something, it usually should be about like increasing or decreasing the number to a certain point. Whereas if you're trying to return like an array of things and you're trying to do it recursively, usually will be when the array's length is at a certain point, okay? Usually. And test it using simple inputs and outputs. Test it first, okay? That's the hardest thing for people to do because testing takes more time, you know? And I'm very impatient, so I never test anything. However, it'll really, really help you, okay? Write your base case and test it with the most simple inputs that result in one recursive call to the base case, okay? That is important, okay? And it will save you guys some trouble. Like how we tested factorial with factorial 2 before we did anything, right? We knew what the answer to factorial of 2 would be, and knew we called it recursively, and we got the right answer, so we think, okay, now let's increase it to 5, you know? Test your function against more complex inputs. Then we tested it against 5, right? It's all about baby steps. Write the base case, test it with a low input that expects a low output, or a simple input that expects a simple output. Then once that's done, increase it and see if it's still correct, okay? Any questions? Oh, so you should try to use Chrome's debugger. It can help inspect recursive calls because console.log will not be as useful with recursion. Console.log could be useful with recursion if you know how to console.log correctly, okay? Like you would console.log what the argument is, you know? And you'll see like when it actually breaks. But the debugger tool definitely helps as well, like I said before. So you can use recursion with any data type in JavaScript. If you're asked to recurse through arrays or strings, the base case often occurs when the iterable is empty or has a length of 1. So imagine finding the sum of numbers in an array. Sum array of 4, if array.length equals to 1, the sum is easy to calculate, right? If the sum of array of 4, the sum is 4. The sum is itself. So that's what you return, right? How we just return that number times factorial of num minus 1. This would be the same kind of thing, except you're returning this number plus some array of 1 less, you know? You know what I mean? So if the base case required the iterable to have a length of 1 or 0, it must mean that the recursive case has to reduce the length of the iterable with every recursive call. It's the same logic, except a different data type, okay? Nested arrays can be approached differently, and I will show all of you how to recursively loop through nested objects and arrays tomorrow, okay? Because I have just taught you everything you need to know about recursion for this course. Tomorrow is recursion 2, and you won't learn anything different about recursion. It behaves the exact same way. I'm just going to show you more complicated things, okay? Like nested arrays and nested objects. How to recurse through them, okay? So the scariest part is over. Well, the workshop kind of sucks, but like, it'll be all right, okay? Cannot emphasize enough, start with the base case. Cannot emphasize enough, test recursive case with simplest possible input that results in one recursive call to the base case. And ask yourself, what type of thing should my function return? The base case and recursive case should return the same type of thing, right? Like, if you're wanting the sum over and over again, like if you want the sum of an array, and then all of a sudden you return like a string at the end in the base case, what are you doing? You know, stop and look at yourself. This is not right, okay? It can't be right. The base case and the function should return the same thing, okay? Same type of thing. Use console.logs or debugger to debug. You know, if you're like not comfortable with the debugger, maybe try out the debugger on your own time later and stick to console logs during the workshop, because you might find yourself spending more time trying to figure out Chrome's debugger than you are learning about recursion, and I don't recommend you do that, okay? But if you are comfortable with the debugger, have at it. If you even need to debug, maybe all of you will get this immediately. Who knows, you know? If you get stuck on a recursive problem, try writing it iteratively. Some people do this, and it makes sense, right? Like, before you start thinking about recursion, let's start thinking about what we need to do to solve the problem in the first place, right? So, it can reveal the inner workings of recursion to just see how you normally would do it. So we talked about recursion, the call stack. We talked about these two examples with countdowns and factorials. We talked a little bit about recursion with arrays and strings, and then some tips for approaching recursive problems. Are there any questions before you take a break and get your hands dirty with the stuff? Any questions from me about anything?
Does Chrome debugger?
Yeah.
This is the first time I've heard of it.
We talked about it a little bit in the loops lecture, which was day 2.
Oh.
Yeah, so like I said, like if you're not familiar with it, I would look into that on your own time later, so you can spend more time focusing on the problems in front of you instead of figuring out how to use the debugger.
Okay.
Okay? The debugger does not work in Revit. Any other questions? Yeah.
Can you please explain what a negative index is on slice?
Negative index?
Yeah, like you know how you're talking about like recursive through a string? You slice a lot.
Yeah, so like a negative index for slice, like if I did like slice -1, you would get the last element.
Just the last one.
Yeah. Like if you do slice of 0, you get the entire string. If you do slice of 1, you slice off the last element. I mean the first element, right? And then you get the rest of it. If you do slice of -1, it basically starts from the end and goes that way, you know? So it's like -2, you would get the 2 elements, right? Like, I'll just show you. Like, if I console.log example.slice of -1, I'd get E, you know? -3, I would get CDE. It's just that do you remember when you made the slice function yourself in the workshop? And if it was a negative number, we just made it a positive number? That's kind of like what slice is actually doing, you know? Because there is no negative index. However, if it is negative, that just means the starting point would start counting not from the beginning of the string or array, but from the end. That's all that is. All right, guys, take a break, take a 5-minute break, and I will slack out pairs, and then you will start the workshop, okay? Good job, guys. Good job.